Hi, and welcome to section 5, where we'll discuss optimizations to improve app startup and performance. We'll learn how to use the Kotlin Bytecode tool to observe additional overhead, using late and lazy properties to delay initialization, inlining high-order functions to avoid additional Java calls, applying const to companion object properties to avoid generating extra methods, and using sequences to avoid creating temporary lists. In this video, we'll discuss using the Kotlin Bytecode tool to observe additional overhead. We'll introduce functions for recording elapsed time, how to use the Kotlin Bytecode tool for displaying the equivalent Java code, and how to spot bottlenecks in Java code which can result in performance issues. The purpose of this exercise is to compare two Kotlin loop functions to see how long they will take to complete an operation. And then we'll use the Kotlin Bytecode tool to help identify any potential bottlenecks in the equivalent Java code. But let me first introduce you to a function just for recording the elapsed time. I'll first create a value just to hold our elapsed time. Now I'll call a function measured time milliseconds. And you see we've got two functions here. You can measure the time in milliseconds or measure nanotime, but we'll use the milliseconds function. Now I'm going to create a function which is just going to do some comparisons in a long loop. I'll pass in a count parameter. I'm just going to create a value here just to help with the operation. Now create a for loop that will start from 0 and complete at the value count. And just do an operation to check whether or not I can be divided by 2. So the purpose of this for loop and operation is just to see how long it takes to execute. So we can now call the for loop inside the measure time milliseconds function and pass in the loop total value. And now let's display that value and run the code. And as you can see, to complete the for loop operation, it's taking 6 milliseconds. Now let's create another function that's going to do the same job as the for loop, but it's going to use a range instead of the for method. I'll call this function for each. And again, it's going to take a count parameter. We will provide it with the variable check, the same as in the previous function. But in this case, we're going to create a range, start from 0 and go up to count, and select the for each extension function. And now we can do our check operation. In this case, I need to select the it keyword because the it represents the item in our range. Now I'll create another milliseconds function just to measure the time that this function takes. In this case, I'll create a value called for each time. And we can call our for each function and again pass in the loop total and display that and run the code. And this particular function is taking around 10 times longer, even though it looks like it's doing the same operation. We can actually look deeper here to see what would be the reason for the performance difference of these two functions. So let me introduce you to the Kotlin Bytecode tool. If you select Tools, Kotlin, and show Kotlin Bytecode. And we will need to select the Decompile tab. We can now close down this right-hand section. And here we have the equivalent Java code. Now I'm not too worried about the main function. I just want to focus on the for each and for loop. So we'll check the for loop first. That was the one that ran faster. And if we look at it, we're just creating a couple values, doing everything inside the while loop. And I don't see anything suspicious that could result in any performance bottlenecks. Now let us focus on the for each function. And on this line here, we can see a couple of things happening. We're creating an object that will involve a bit of work. It's a range object. We're creating an object. Then after that, we're going to see if that int range object can be cast to iterable. And it also involves a bit of work because it needs to check to see whether or not the iterable can be cast, and if not, it will throw a class cast exception. So there's a little bit of work happening on this line. If we look at the for loop, I don't see anything suspicious on that line. Now let's look inside the body of the for loop, and we can see our variable 3, which is an iterator. That's now going to be cast to an iterator. And again, that's going to involve a bit of work just to see whether or not that can be cast. If not, it will throw a class cast exception. And this casting check is happening on every single operation of the loop. So potentially this can be what's causing our potential bottleneck, which is why it's taking longer to run this particular function. We'll learn about Kotlin functions, which are useful for recording elapsed time of operations, and how to use the Kotlin Bytecode tool for viewing the equivalent Java code for identifying potential bottlenecks.